Hello learners, and welcome to a video tutorial about the physics of halo. Now, this is halo reach, and later we'll be investigating halo 4 and if possible halo 3. But for right now, here we've got Master Chief and his friend here is taking a nap, and we're going to throw it at a certain angle. I'm going to arc it pretty high. And I've already tracked the, it's a sticky grenade, over this room here. And we'll be able to watch in real time its Y position. And I can also switch this and show you the X position versus time. Now, we know that we generally neglect air resistance for things moving in our classroom. Because for the most part, it can be negligible, the effects. And if that's the case, then the only acceleration is in the y direction. And we're going to assume that the acceleration is constant in this realm. Now, for a constant acceleration, you end up with this parabolic position versus time graph, which we do for the most part get. So let's watch in real time this toss. And so you can see the ball, or excuse me, the grenade reaches its max height where its y velocity is 0. Then it starts its progress down, and then it eventually hits and bounces one more time before finally coming to a stop. And you can see that right here, this very small little parabola. And then, fun. Now, let's look at the x position graph. If there were no air resistance, then there would be no acceleration in the x direction, which we would expect linear position versus time graph for the x, and voila. For the most part, it is pretty linear. Now, there are some bumps here and there because the video jumps frames, because this is a recording of a recording, but you get the idea. Here's where the ball is traveling through the air. And notice how I have a negative slope. If you look here on the graph, I made my origin right here where the Master Chief started. So the ball is traveling to the left. So we'd expect a negative x velocity. Now look what happens right here at this point. Our slope shifts because the grenade hit the ground. It had a different velocity after it hit. And we can see that right here. Okay? So it had a slower velocity. It lost a lot of energy when it hit the ground. Now, how accurate is this? Well, we'll go more in depth to that whenever we can analyze the graphs here. But let's say I wanted to figure out, well, okay, what's my x velocity? Well, I could, if I wanted to, highlight, and I could do a linear fit on this. And so I could say, okay, I want a linear fit on that. Well, right here, this 1.859, that's the initial x position. And right here, that would be my x velocity, negative 5.9, and then some units per second. This isn't scaled properly because it's a video game, but you get the idea. So, more to come on the science of video games.